Hello class, it's Mr. Stakem here. I hope we're ready for science class. Let's make sure we have all of our things out. You'll notice that you have a ruler, a marker, a pencil, and today's activity on our desk. We leave those alone for one quick second while I introduce our lesson for today. So a lot of times in science class, we're going to integrate math and doing calculations in our work. Today, we're going to be looking at scale factors and how we convert units of measurement from one system to another system. For example, centimeters to meters, meters to feet, and all sorts of other things. To get us used to this activity, we're going to be inventing a smoot and a hoot. Interestingly, in 1958, a group of MIT students set out on Massachusetts Avenue to measure a new bridge, and they wanted to use their own measurement. They took the height of one of the fraternity brothers, Oliver Smoot, who was 5 feet and 7 inches tall, and they used him to measure the entire length of the bridge. We're going to be starting our practice with converting a smoot to feet and inches, and then to meters. I'm going to walk as we get started with our unit. Pick up your ruler. You'll notice one side has numbers in inches and the other side has numbers for centimeters. 1 inch is a lot bigger than 1 centimeter. As I previously mentioned, the fraternity brothers at MIT measured the Massachusetts Avenue Bridge in 1958 once it was put up. They figured out that it was 372 smoots. Smoot was one of the fraternity brothers, Oliver Smoot, and he was 5 feet and 7 inches tall. Important thing to note, 1 foot is 12 inches, and 1 meter is approximately 39.37 inches. To start us up and warm us up, we're going to convert smoots to inches and inches to meters. That way we can figure out how long the Massachusetts Avenue Bridge is in meters. We're going to get started with our scale factor and dimensional analysis practice. We'll walk together on the first one. That way you can run when it's time for you to go independently. So we're going to convert smoots to inches and then to meters. First up, we need to figure out how many inches are in 1 smoot. We know that in 1 foot there are 12 inches and 1 smoot equals 5 feet and 7 inches. We're going to multiply 5 by 12 and add up 7 to figure out how many inches are in a smoot. So we'll write it out. 12 times 5 equals 60. We'll add up our 7 and we get 67 inches in a smoot. From here, we're going to move over to our scale factor. We know that there are 372 smoots in 1 Massachusetts Avenue Bridge. Before, I might have mentioned that we need to include our units. That way we can make our lives very easy. We know that smoots was our starting point, so that's going to start in our top, in our numerator. We want to cancel out smoots. That way we're left with inches in the bridge. We just figured out that there are 67 inches in 1 smoot, so we could write 1 smoot at the bottom, and we'll include 67 inches on the top. From here, we could cancel out our smoots, and we're left with inches in the bridge. We're going to multiply the numbers on the top and divide by the numbers on the bottom. So we will do 372 times 67. What's 7 times 2? Ishan? 14, correct. Great job. 7 times 7 will get you, what's that, Rom? Don't forget the 1. Right, we'll carry that over and we'll put a 0 and a 5 here. 7 times 3, 21 plus 5, we got 26. Great. Now we're done with the 7, we'll cross that out. Now we're dealing with our 6. First we'll start with the 0 right here. What's 6 times 2, Ayan? Yeah, 12, great job. We'll put that 1 up there. We'll erase that 5 because we don't really need it anymore. 6 times 7, Johan? Right, 42. Don't forget that 1. Yup, 43. We'll put a 3 there and we'll carry that 4 here. 3 times 6. What's that, Rajan? A little bit higher, add 3 more. Right, 18. 18 plus 4 will get us 22. Let's total that up. 4 plus 0 is 4. 0 plus 2 is 2. 6 plus 3 is 9. 2 plus 2 is 4. Great job. And we could bring down that 2. So we figured out that the Massachusetts Avenue Bridge is 24,924 inches. We'll hold on to that number for a second. So I mentioned that we're going to convert smoot to inches and then inches to meters. We know that in 1 meter, there are 39.37 inches. We have inches up top here, so we're going to put inches down here. And we figured out 39.37 inches equaled 1 meter. Inches are going to cancel each other out. That way we're just left with meters when we're all said and done. So we could take the 24,924 that we got from multiplying the top, and we're going to divide it by the number on the bottom. So 1 times 1 will get us 1, and 1 times 39.37 will get us, 39.37. Good job, guys. So we're going to divide 24,924 by 39.37. This is a little bit tricky. Does someone have a calculator that they could use to do this equation really quick? Ishan, could you plug that in? 24,924 divided by 39.37. Don't forget that decimal place. And you got how many? 633.06. 0.06 what? What did we leave behind? Great job, we left behind meters. So we got 633.06 meters. I know last week we worked a little bit on scientific notation. Maybe we could apply that skill to this right now. Could we round the decimal place? Yeah, we can, because the 6 is greater than 5. So really we've got 633.1 meters. And scientific notation was moving the decimal place over and multiplying it by 10. So we're left with 6.331. And how many times did we move the decimal place over? 1, 2. So we're going to multiply this by 10 to this 2 exponent. Don't forget your meters. So we figured out that the Massachusetts Avenue Bridge 372 smoots, 24,924 inches, is really 6.331 times 10 to the second meters. Good job, class. Now you're going to be working a little bit independently on this, but this is a fun and engaging activity. As we said before, we all have our rulers. You're going to pick 2 items anywhere in that you have on you right now and measure them. I recommend doing one kind of small one and one slightly bigger. For this example, I'm going to use a pencil and my laptop. Okay, class, did we all decide what our objects are going to be? As I said, I'm going to use my pencil as my small object equal to 1 smoot. I'm going to use my laptop as my larger object, that's 1 hoot. First, I'm going to take a measurement of my pencil. I'm going to take the end of the pencil all the way at the eraser and start it on the 0 mark. I've got it in place. I'm going to compare it, and it's exactly 6 inches or 15 centimeters. So I can write that down. My small object is a pencil, and it's equal to 6 inches / 15 centimeters. Now I'm going to measure my larger object. I'm going to use, what length? What is this? I might have just gave it away. Yeah, Johan? Yeah, this is the length, and this could be the width. So measuring it from the end all the way to the other end is exactly 12 inches or 30 centimeters. We've got a nice and easy round number for this. So my laptop equals 12 inches or 30 centimeters. Is there another unit of measurement that we could classify this laptop in? Right, good job. It's exactly 1 foot for the length. What about our pencil? Yeah, it's exactly half of 1 foot. Great job. Now, we're going to convert how many smoots are in our larger object. So our laptop, 1 hoot, is 12 inches. We'll put inches at the bottom to cancel. And we'll put smoots up top. We, to figure out a hoot, 1 smoot is worth 6 inches. So we could divide 12 over 6. The fraction 12 over 6 is equal to, what's that, Gray? 2? Great job. So we canceled out our inches, and we figured out that 1 hoot is equal to 2 smoots. Yeah, I know, it's a funny name, but Smoot was a pretty smart guy because he's helping us learn scale factors and dimensional. Right. So using our scale factor of 1 hoot equaling 2 smoots, you're all going to independently convert 236 smoots to hoots. I'm going to set up and work up here as you guys work, okay? So 236 smoots is my starting point. I've got smoots up in the top left, Now I'm going to have to cancel it out in the bottom right. So I could put my smoots down here. I'll give you guys a second to catch up. Okay. And how many smoots are in one hoot? Awesome. 2 smoots equals 1 hoot. Ooh, my marker's starting to die. I guess I have to get a new one. So I have to convert smoots to hoots. I got smoots, I got my second smoot, and I got my hoot. We're ready to roll. We could cancel out. 236 times 1 will get us 236. And I've got 2 smoots, or 2 on the bottom. So we're going to divide 236 by 2. 2 goes into 2 one time. 2 goes into 3 one time. Great. And it leaves a 1 over, right? So 2 goes into 16 how many times? Right, 8. So that means in 236 smoots, we have 118 hoots. Can anyone try and put that into scientific notation for me, or walk me through the steps? Okay. So we'll move the decimal place over. 1, 2. So there's 1 number to the left. Great job. We've got to put our times 10 and our exponent. How many times did we move again? Ah, great. So to the 2 hoots. So 236 smoots is the same as 1.18 times 10 to the second hoots. Okay. Great job. For our final example that we'll walk through together, we're going to be working the other way. Before we went smoots to hoots, now we're going to go from hoots to smoots. Keep in mind, 1 hoot equals 2 smoots. For this one, let's convert 22.5 or 22.5 hoots to smoots. All right, I'm going to listen to you guys. You're going to walk me through this one, okay? So, yeah, we got to start with our starting point, which is great, 22.5. 22.5 what? Hoots. Great job. We'll keep going with our scale factor. What else do we need? Yeah, we need hoots on the bottom. And how many hoots to smoots? 1 hoot to 2 smoots. Great. Okay. Am I all good? I'm ready to do my calculation. Right, we are. So we could cancel out our hoots, and we're left with 22.5 times 2 smoots on our numerator over 1. 22.5 times 2. 5 times 2 gets us 10. Great job, class. Add that 1 over. 2 times 2 plus 1. 5. Awesome. 2 times 2, 4. Yeah, you guys got it. Wait, 22.5 times 2 equals 450? What did we forget? Ah, yeah, the decimal point. Will it go here? Here? Oh, here. Okay. So 22.5 hoots is the same as 45 smoots. All right, for the next part of class, you're going to be working with your lab partner, working with experimental data. Please get with your lab partner, and when you're all ready, one person come up to my desk, and I'm going to give you a value for a short distance and a long distance. It's going to be different for every person. Okay, now that we've all had a little time, I'm going to work through one of the examples I gave you. So I believe I gave Ishan and Dahan a short distance equal to 6 smoots and a long distance equal to 5 hoots. We're going to deal with our smoots and our short distance first. Keep in mind, 1 smoot equals 6 inches or 15 centimeters, and 1 hoot equals 12 inches or 30 centimeters. So our first question was to convert the short distance from smoots to centimeters, making sure that we put our answer in scientific notation and rounding to the nearest hundredth place. So to start us off, we're converting smoots to centimeters. So we started off with 6 smoots was equal to, what's the unit we need to cancel? Good job, smoots. And what was the unit we needed to end up with? Yeah, centimeters. How many centimeters are in 1 smoot? Right, 15 centimeters in 1 smoot. What do we do next? Yup, cancel out the smoots. And we're left with 15 centimeters over 1. We can multiply the top. 15 times 6. 6 times 5. Good, 0. Put it 3. 1 times 6, 6 plus 3, 9. And what are we left with? Centimeters. So 6 smoots is the same thing as 90 centimeters. Is this in scientific notation? No, so let's convert that. We move the decimal place 1 time. So it's really like 9 times 10 to the 1 centimeters. An example, we're going to be converting the long distance of 5 hoots to centimeters. Again, scientific notation and rounding to the nearest hundredth if necessary. So our starting point was the hoots, and we want to get it to centimeters. So we got 5 hoots. We're going to cancel hoots. And yeah, we can put smoots up top. That means we're going to do an extra step on our scale factor. We're going to have to convert our smoots into our final unit, centimeters. So now we've got to fill in the blanks and put in our numbers. We know that in 1 hoot, we have 2 smoots. Good memory. And in 1 smoot, we have 15 centimeters. Awesome. So we've got it all set up. We could cancel out. Hoots cancels with hoots. Smoots cancel with smoots. And we're left with 5 times 2 times 15 centimeters over 1. So we'll do 5 times 2 first. 5 times 2 gets us 10. And then we could do 15 times 10. You guys remember the trick multiplying by tens, right? We could take that 0, put it down first. And we're left with 1 times 15, which is 15. Putting it all together, we have 150 centimeters. Let's convert it. How many times are we moving the decimal? Great job, 2. So we have 1.5 times 10 to the 2 centimeters. So our long distance of 5 hoots is the same as 1.5 times 10 to the 2 centimeters. One more extension activity for us, and this is going to be moving on to our next unit. So we'll see how it goes and we'll do it together. we're going to be converting our answer from centimeters to meters. So for our short distance, we got 90 centimeters, converting it to meters, and 150 centimeters for our long distance to meters. So remember, kilo, hecta, deca, base unit, which is similar to meters, deci, centi, and milli. So if we start at centimeters and we're moving to our base unit, we're moving 2 times, right? So we're gonna move our decimal point just like how we move 2 spots to the left here, 2 spots to the left here. So 1, 2, and then we've got it. 0.9 or 0.9 meters is the same thing as 90 centimeters. You guys try out this one. With 150 centimeters, same deal. We're going to move 2 times to our base unit of meters. So we can move the decimal place 2 times, and we're left with 1.5 meters. 150 centimeters is the same as 1.5 meters. All right, class, with the remainder of class time, you can continue working with your lab partner to finish up that worksheet packet. I think you have about 4 on this page and 4 more on the next page. We are going to continue using smoots and hoots for this activity, but keep in mind that those are made up measurements that we don't actually have in real life. We do use inches and feet because the United States uses it, but we also use the metric system more often here. All right, so for possible modifications for students with learning disabilities, I would consider using smaller and easier numbers. That way it's a little bit easier to handle the numbers in the calculations. And I would also consider reducing the number of like and similar problems. Before I mentioned 8 possible extra practice with the lab partner. I would consider maybe doing 4 to 6, depending on how much time the class has and how well the students are picking up this skill. Some skills that the students are working on are math calculations, specifically multiplication and division, and understanding units, and kind of applying them to their daily life. Like they'll realize that this pencil is just about 6 inches, where this computer is about double that distance. I mean, I'm not doing a great job of demonstrating that, but they'll start to put things into context of bigger, large. Thank you so much for making it to the end of the video with me. I hope you could use some sort of activity like this for dimensional analysis and scale factors if that ever comes up in one of your classes. It is an important skill to work on, especially if kids are traveling, if you have international students, etc. As I said, thank you again for making it to the end of the video. I hope you have a great day. See you later.